Hello everyone, welcome to Arif Science Hub, your pathway to success in Edexcel level computer science. It's me Arif Islam. Today we're going to talk about software, that is chapter 4. In this chapter we will have two lessons, lesson 4.1.1, and in this lesson we're going to talk about software, system software, and it's including operating system. Lesson 4.1.2, where we're going to talk about application software, utility software, file management tools, security tools, then computer simulation and modeling. So let's start. So every computer basically consists of the hardware and software both, and software is a collection of instructions or data that tells the computer how to work and what to do, what not to do. So computer consists of physical hardware from which the system is built and actually perform the work. Okay, so software means it is just the instructions. Okay, it's just the command to tell the physical components or computer how to work, how to operate. Okay, so software is nothing, it's just a set of rules, set of instructions, or set of programs. Okay, so there are two main types of software: system software and application software. Okay, so we'll discuss both in details. So system software. System software helps to run and maintain the computer. It includes the operating system drivers and utility softwares. So first of all, we have to know about the operating system. I hope you know about it, but till then we have to know in details about the operating system. So operating system is the biggest part of the computers. That means how the hardware will work, how the hardware will be maintained or managed. Entirely it will be controlled by the operating system. That means how much the physical memory will be used, how much the processor will be allocated for the applications, and the security features and the applications. That means lots of applications you might run in the operating system that also can be maintained or controlled by the operating system. All computers have an operating system. They cannot operate without one. So that means for every computers you need an operating system so that they can operate or they can work. So there are different types of operating systems are available. Most popular operating systems are including Windows, Linux, Mac, OS X, Android, iOS. All those are operating systems that will operate the hardware or the device or the systems. So there are some relationship between software and hardware. You can see in this figure, it will be clear how it helps or how it operates the software and hardware for the user. Okay, so hardware is the physical part of the computers. That means the CPU, the input output devices, the peripheral devices like the keyboard, mouse, the trackpads, okay, the webcam. All those are peripheral devices. RAM is the memory and the CPU. So all those are physical components, and this component will be managed by the operating system. You can see here, this is the operating system, and on the operating system we have system software and others application softwares, and user will be interact with the operating system. You can see they have the user interfaces that will be provided by the operating systems, and user will interact through the user interface, and those user interface will be maintained by the operating system, and how the hardware will work, that also controlled or managed by the operating system. So software versatility, that is very important for the relationship between the software and hardware, because some general purpose computer software is designed to run on diverse hardware platform. Okay, that means you have a software that might be run on a laptop, on a desktop, mobile phones, or tablet computers, as like your Google Chrome browsers. It's a applications. You can run this application on cross platforms or different platforms or different hardware devices. And operating system management. Operating system handles input, output, or peripheral devices for the computers, and it will just take some commands from the programmers. Like if you want to manage something, or if you want to just give some instructions or give some command to the computers, like open the file, it's a command. If you put the command to the computers, it will work through the operating system, because operating system tells the hardware, and it will arrange the environment so that the command will work for the programmer. Then abstractions in actions. Abstraction simplifies programming by allowing generic commands. It's like open file. It's a generic command that recognize it will give some instruction to the hardware devices or hardware components. So the operating system handle the specific depending on the type of secondary storage, so it will control or manage the memory or secondary storage. Then compatibility challenges. So application need to be written for a specific operating system but can run in any hardware. Okay, suppose you have on Android operating system. So if you have any application for Android operating system, it will run in any Android operating system devices. That means those devices that will run in by operating system, that means Android operating system. But for Apple devices, those are not going to work like this, because for Apple operating system, that means the iOS operating system or Mac OS operating system, they are specifically work with their hardware devices. That means any Mac software or any iOS software not going to work for Windows operating system or those devices that installed or operated by the Windows operating system or the Android operating system for Apple phones. Okay. Then the operating system provides developer of application program like word processor, Microsoft Excel, PowerPoint, and for displaying some images like the image viewer. And this is a set of command usually called application programming interface or API. That means by using those interface, it will gives us some feature to access for the computers. And operating system controls what application program are allowed to do. That means how the application software going to work, it will be defined by the operating system. That means how much physical resource will be allowed for the applications, how the application will interact with the hardware, everything will be managed by the operating system. So all the input output or peripheral devices will be also managed by the operating system, and operating system share access to the hardware across different programs that are running in the system, and it will also handle or manage for sharing the CPU or random access memory. And we have several terms for the software or hardware components like scheduling, paging, and swapping memory. So scheduling means we know that for our CPU it will just process the instruction one by one from the fetch decode execute cycle or fetch decode execute model. Okay, so scheduling means when you have several applications open, they can relay by running simultaneously. Okay, so the operating system keeps up this illusion by allowing each program to the CPU for a short time before switching to the next program. That means it will give some illusion that the program is running, but basically it's not simultaneously running the program. It's just giving some space between the programs. That means it will just running some instruction for an application or program, then it will pause for a moment, then it will run for another applications, then pause for a moment, then it will run another applications. So it will create an illusions of the applications so that the inter-system or others application won't be crashed. Okay, so paging and swapping memory. So it is possible to load many applications at the same time. So each user or each applications will use some memory. Okay, so what if you keep loading application until the RAM is full? That means you will just keep opening the applications. It's not going to work like this. So what if you keep loading application until the RAM is full, and in this case the operating system creates another illusion by moving program from RAM to hard disk. That means you open multiple applications and your RAM is out of storage. What will happen at that moment? At that moment, the operating system will create some illusions to the applications. So they just swap the program from RAM to secondary storage. Okay, so in this case, the memory will be controlled or managed by the operating system. That means when you will have, suppose you will have 4 GB of RAM, so at the time you are just running multiple applications. So what will happen in this case? So suppose you have 4 GB of RAM and you are running some application that is not capable to handle by 4 GB of RAM. So at that moment what will happen? So the operating system will just move these applications from primary storage, that means RAM, to secondary storage. So at that moment your system will be slowed down, but still then it's not going to crash. It will be work fine. Okay, and the operating system create the illusions for the programs for RAM and hard disks, so that it will be managed properly for the applications. So it has some problems by the swap memory. That means we know that our RAM or primary memory is very fast, but the secondary storage are not that much fast. So when the program will be moved from primary storage to secondary storage, that means RAM to the hard disk, then it will be slowed down the system. Okay, so some features of operating system. So operating system has lots of features available. So we have to know the features of the operating system. So we are going to discuss about the features of the operating system. Okay, so you can see operating system will control and backing store and peripheral such as scanners, printers, mouse, keyboards. All those peripherals will be controlled by the operating system, and deals with the transfer of programs in or out of memory. That means when the program or instructions or any data will be passed through the memory, it will be also controlled by the operating system that organizes the use of memory between programs. I told you that operating system will be managed, the hardware components like the memory, the CPU, those will be managed by the operating system. So it will organize the memory between different applications. Suppose you have running multiple applications on a device, then it will the operating system will organize your every applications. Okay, like you are running any word processing applications, image editing software, like your web browsers, and then any other applications like any video game, any video player, all those applications, any notepad. So at that moment the operating system will organize the memory, which applications, which program will take how much memory, how much the CPU will be allowed to the applications. It will be organized or managed by the operating system. Then organize processing time between programs and users. So user will interact through the operating system, so it will also be organized by the operating system, how processes are going to work. Then maintain security and access rights of users. So it gives us some authentications to the system. That means for operating system you will have to log into the system, and that is called authentications. You have to put the username, password to the system, or any pin code to the system, so that you can just easily log in to the system. So this feature will be provided by the operating system, and deals with error and user interactions. So lots of error will be can be occurred to the system. So the operating system will deals with those errors and the user interactions also. So operating system allows user to save file and the backing store. That means all the file or all the documents that you're going to work through in the system, that must be saved to the system. So how you can save the file, it will also be allowed by the operating system, and it provide interface between the users and the computers. For example, Windows, Vista, Apple OS X. For more information, you have to see the user interface or interface study guides, and it will give us some error message, so that it will be very clear to us that what's wrong with the system. We can easily identify or troubleshoot the problems. That means it will gives us proper error message, so that we can easily identify the problems and troubleshoot the problems. Okay. Then application software. So application software helps us for our everyday task, and we have lots of application softwares available that will be used by the system, or the application software just help us to accomplish a specific task or some special task, like writing emails, then creating posters, completing homework, messaging friends. All those are application software. That means that they are used for special applications, specific applications. And word processor, web browser, graphics softwares, those are application softwares. Okay, because they are used for specific applications, specific purpose. And general purpose software. So certain software like word processor, spreadsheet, or desktop publishers is versatile, capable of handling a wide range of tasks. That means a single application can do multiple tasks. And flexibility. So user can perform diverse activities within a single applications. Then special purpose software. So specific task focused software, such as flight simulator, payroll tools, or math revision application. Those are special purpose software, and it's very spacious and it's tailored to excel in a particular function or domains. Okay, so smartphone applications. Applications are not exclusive to computers, they are also in the mobile phone devices. Okay, that means for the smartphones, and we will use lots of applications for the smartphones, like social networking, music listening, messaging, for making phone calls, or making capturing any video, capturing any photo, images. For lots of purposes we can use different applications. Like if we need calculator, we can easily install an applications called calculator, and it will be used in the smartphone. Okay, so it's a application software. Then utility software. So utility software perform essential task user, but not the primary reason for using a computer. That means for using a computer you don't need any utility software, but utility software performs a specific or essential task from the users or for the users. Okay, like a company or organizations need a payroll softwares. That means payroll software does not required for everyone. That means those payroll software is important for a specific organizations, a specific institute. Okay, and it is essential to the operating system but adds value to the user experience. So computer will be used for the user requirements. Some different user has their different requirements, like some young peoples like to play video games. Okay, but some developers like to develop softwares. So like the kids gonna use the computer for playing video game, but for the developer not gonna work or not gonna use like the same purpose. Similarly, for some organizations, they have their own purpose. They will use it for their own purpose, and for fulfilling those type of purpose, we can use the utility software. So there are three key areas like basic tools, file management, and security for the utility software. So for example, text editors like Notepad, calculator, command prompt, and hex editor. Accessibility software, it facilitates features like large print, enhancing user experience. File management, it's like streamlines organization, storage, and retrieval of files. That means easily you can organize all the files by using the file management. And the security, it protects the system from threats and vulnerabilities. That means we can easily protect it from the threats or vulnerabilities. There are some basic tools overview, like including the operating system, and it's often integrated into the operating system, and diverse functions. So ranging from simple text editor to accessibility enhancement, it will also be managed by the utility softwares. Okay. So I hope it's very easy to understand. So if you have any problems, any confusions, you can comment and I'll just give you the answer. And you can visit arif.sciencehub.com. Then you will find your every required components or every lectures over there. Okay. So file management tools. In the file management tools, we have defragmentations for efficiency. So for hard disk drive, we know that we have different types of secondary storage. For it's especially for magnetic storage. That means the hard disk drive defragmentation is very important, because in fragmentations we have a file will be divided into multiple parts, so that we can just store those data or file or the information in a small amount of time. Okay, and those files will be stored in a different memory locations. But defragmentation means those fragmented file or the part of the files will be collected together and regain reconstruct the file so that we can access it. So defragmenter roles, so recognize file fragments and optimizing access speed, particularly on magnetic hard disk drives. Basically, this fragmentation or defragmentation is needed for magnetic storage or hard disk drive secondary storage. But for solid state drive or flash drive, this fragmentation or defragmentation are not that much important. Okay. So compression for space management. So compression of the file is important for just the capacity of the storage, because if we compress the file, we can just make a smaller size of the file. That means some file we don't need to use this frequently. What will happen on those files? So some file that we cannot use frequently, so we can just compress the file and store it, because compressed file need longer to access it. Okay. Okay, security tools is a types of softwares that can prevent the threats or viruses or from the hackers. So it's a different types of softwares that's basically protect against computer virus and spywares. Sometimes some virus can be attacked to the system, and at that moment the security tool software will protect us. And virus protection dynamics, so virus behavior, sometimes different virus basically behavior differently, like it replicates itself and spread over the systems. And the antivirus basically will find those types of virus and they prevent for malicious activities or processes. Then firewall. So firewall is a types of software that can prevent the network security, like the incoming traffic or outgoing traffic to the system. It can be controlled by the firewall, and it will determine which connection are allowed and which connection are not allowed. That means which data will be incoming or outgoing data will be controlled by the firewall softwares, and firewalls can be software or hardware both. So the firewall software will control the network part of the systems. Then encryptions for confidentiality. So sometimes the data must be encrypted for the safeguard, because if the data or packets will hand over to the third party or some hackers, then they cannot read the data, because encrypted data need to be decrypted first to read or extract the information from there. So encryption is another way or another method for protecting the data. Computer simulation and modeling. So virtual experiment beyond reality. Sometimes we need to make some experiment of some systems, not in reality but virtually. So that type of system is called computer simulation and modeling. And some example scenarios for manipulating the earth average temperature for weather predictions. So actually in reality it's not possible to measure the temperature over the entire earth, but we can make a simulation of the temperature of the earth, and empowering experiment impossible in the real world that can be experimented by the help of computer simulation and modeling. And it basically works through what if capability, like scientists, engineers or economists just leverage computer models for hypothetical scenarios. So for example, what if the bridge were twice as long? Okay, so in reality it's not possible for make the bridge twice, but in the computer system or by the help of computer simulation is possible if the bridge can be twice as length. So we can increase the length and make the scenario for computer simulations. And there are some challenges for the simulations. For assumptions in model simulation include assumptions that basically divert from the reality, and there are some limitations for the computer simulation, like real world complexity requires abstraction for model simplifications, because sometimes it's not possible to find out the all possible ways or complexity in the real world. So these limitations will occur in the computer simulation and modeling. Then reality versus simulations. Definitely we will have some differences between the reality and the computer simulations, because computer simulation is entirely virtual. It's not related to the reality or real world, but still then it can give us some assumptions or some abstractions, role or balancing act between simplification and capturing essential factors, and revealing insight and imperfections. So the computer simulation is not perfect, so we can call it as the imperfect system. Like we can just give an idea about the environment, but it won't be able to give the accurate or actual data or information by using the computer simulation. So that's all for today. So if you have any questions, you can ask in the comments. I'll give answer to all of you. So still then, take care. See you in the next class. Thank you.